The topic of electrochemistry is also directly related to what we've learned before in thermodynamics. So before we talked about delta G, the Gibbs energy. Now we're talking about the standard voltage E0. So if a reaction is spontaneous, we know that the standard voltage will be a positive number. And if you multiply a negative, N is the number of moles of electrons lost or gained, so that has to be a positive number. And F is called the Faraday constant, which is a positive number. So this is going to work out to give you a negative answer for delta G. So whenever the voltage is positive, it's spontaneous, which matches what we learned before about delta G being a negative number. And under standard conditions, we can write the superscript 0. This Faraday constant is the charge in coulombs of 1 mole of electrons. We can also relate the standard voltage of the cell to the equilibrium constant capital K by this reaction. 0.0592 is a constant for 25 degrees. N is the number of moles of electrons, again, lost or gained. So for example, in this reaction, we have a reduction of 1 electron being gained and an oxidation with 2 electrons being lost. But there's only one value of N to substitute, and we had to multiply the first half reaction by 2. So in this case, N is going to equal 2. It has to be the same number whether you're looking at the oxidation or the reduction. The overall reaction is written here, and then you have the equilibrium constant K. Products divided by reactants. Solids don't appear in K. And let's just say that this equilibrium constant is a small number, 1.3 times 10 to the negative fifth. A small number of K, remember, means this reaction favors the reactant side. And if the reaction favors the reactant side, if we plug it into this equation and we take the log of that small number, and we're going to calculate the standard cell voltage, and this standard cell voltage will work out to be a negative number. So the negative number means the reaction is not spontaneous the way it's written, which is directly related to the fact that the equilibrium constant favors the reactant side.